In this video, we will cover different types of microphones and what some of the important differences are between them. First off, let's cover some important terms. A transducer is a device that converts one type of energy to another. A microphone is a transducer that converts sound or acoustical energy into electrical energy. A diaphragm is a thin membrane that moves with sound pressure changes. Phantom power is a DC voltage of usually 48 volts, though it can be less, provided by a mixer or other device like a battery. A polar pattern or pickup pattern describes the directionality of a microphone or how sensitive it is in relation to where the audio is coming from. A lavalier is also known as a lav mic or a lapel mic. This is generally a small microphone used to mic someone hands-free by clipping to the lapel area on a shirt. Feedback is the screeching sound that occurs when a sound system amplifies itself. There are various types of microphones, but only dynamic microphones and condenser microphones are used at Daktronics. Some common places dynamic microphones are used are the announcer's microphone and handheld microphones, with some examples being a Shure SM58 and an Electrovoice RE20. Some common places condenser microphones are used are the announcer's headset, referee mics, and other microphones potentially sold with a custom system. Some examples are the Bayer Dynamic DT287 headset, Shure WL185 lavalier, and Shure MX150 lavalier. Dynamic microphones are a simple design. They use a magnet and a coil that is attached to a diaphragm that moves due to sound pressure changes. That converts the sound into small signal voltage. This works similarly to a speaker, which converts electric signal voltage into sound. In fact, you can wire a speaker transducer to a mixer input and talk into it, and it will work as an inefficient microphone. Dynamic microphones do not require phantom power to operate, since it is the movement of the coil over the magnet that generates signal. Dynamic microphones are generally the most robust. They are practically impossible to overdrive, and they are not particularly sensitive to temperature and humidity changes. Condenser microphones use an electric charge to form an electric field between a backplate and the diaphragm that works like a capacitor. The electric field changes when the diaphragm moves due to sound pressure, and the gap between the diaphragm and the backplate changes and creates the signal voltage. Condenser microphones require phantom power to provide the electric charge for this process and for the circuitry involved in this process. Due to built-in circuitry, condenser microphones can be overdriven with very loud sound levels and should not be used on particularly loud sources. This does not apply to most cases in Daktronics systems because we mainly use microphones to pick up vocals. Condenser microphones can be sensitive to extreme temperature and humidity and can potentially stop functioning in these extreme conditions. Next, we will cover the polar patterns or pickup patterns of microphones. An OMNI pattern will pick up signal from all directions equally in open space. They are largely immune to wind noise, which is useful in stadiums outdoors. However, they can be more prone to feedback since they are not very directional. The cardioid polar pattern is a somewhat heart-shaped pickup pattern. It picks up audio mostly from the front and sides of the microphone, tapering off more towards the back. A drawback to cardioid microphones are that they are more susceptible to wind noise. This can be somewhat remedied with a good windscreen. Cardioid microphones reduce the chance of feedback as long as they are aimed away from the audio system, since there is much less pickup in the back of the microphone. Some other polar patterns are supercardioid and hypercardioid. Supercardioid is a similar pattern to cardioid, but has a narrower pickup range in the front and picks up less on the sides. There is some pickup towards the back of the mic as well. Hypercardioid is similar to supercardioid, but has an even narrower pickup pattern and more pickup towards the back. Both of these options have similar benefits and drawbacks to cardioid, but can provide an even more reduced chance of feedback if oriented correctly. There are more patterns out there, but aren't used in Daktronics systems, so we will not be covering them in this video.